this is Britt Caswell with another example video. In today's video, I'm covering the Do You Know How from section 7.6 in the SavvasRealize Algebra 1 textbook. The goal of doing the Do You Know How with you guys is to practice some of our factoring skills when our A value is no longer 1. So question 6 here, it says to list the factor pairs of AC for each trinomial. So when we say AC, just remember, the standard form of a quadratic is ax squared plus bx plus c. And often we multiply together a times c when we go to factor. And so I'm going to be multiplying the coefficient of the x squared term and the constant, and then listing the factor pairs. Alright, so if I take AC, I'm taking 2 times 4. So AC in this case is 8. So my factor pairs for 8 are 1 and 8 and 2 and 4. And what I do for these, not so much for the little numbers, but like for the larger numbers, is I just very systematically go through and multiply by whole numbers. So I start with 1, then I do 2, then I would try 3. But when I reach 4, well, I already have 4 on here. So if I used 4 again, I'd just be repeating. So I know that these are all of the factor pairs that I would need. Alright, so now on this one, AC, so I'm doing 12 times 2, which is 24. Now some would argue that A times C would be negative 24 because technically C is a negative 2. Depending on how you learn how to factor it just depends on what you believe for it. Now personally, I'm just going to find the factors of 24, but some people choose to call them positive and negative, which would double my list. So here we are, I have 1 and 24. Now I have 2 and 12. I have 3 and 8, and 4 and 6. Now if I was the person who thought that AC was negative 24, and again this just depends on your preferences when you are factoring, what I would do is I would double this list, and I have to consider the fact that to get a negative, I have one positive term and one negative term. So what I would do is I'd make the smaller number on these ones negative and the bigger number on these ones negative, and now I have my full list of factor pairs. So see how when I consider it as a negative, it kind of doubles my work? So that just kind of depends on your thinking as you move forward in factoring. Alright, so now on 8 and 9 here, what we're doing is we are looking for a GCF, and then if there isn't one, then we're going to go ahead and try to factor it. Alright, so now that's kind of our goal here. So here on the top, I have 15x squared, 10x, and 5. So I'm going to break this up like I did in the baby days of this stuff. You probably already see it. But if you don't see it, I want to make sure that it's very clear, what our process is. So I'm starting out by taking each term and I'm breaking up into its factorable components. Alright, so here 15x squared is 3 times 5 for 15, and then x and x to make the x squared. And the 10x I broke up into 2 times 5 times x. And so what I'm looking for is the common term here, which kind of sticks out like a sore thumb when you write it like that. That common factor is 5. Now I'm going to take this a step further. It's not telling me to factor out that GCF, but I'm gonna because it's fun. So remember, if you do need to factor out that greatest common factor, I've pulled out the 5 from each term, and everything that's left is what comes here inside the parentheses. So I have a 3, an x, and an x. That makes 3x squared. And I have a 2 and an x here, so that's 2x. And here, where I took out the 5, the thing that's left is a 1. So not only did I identify the common factor, but then I went through and I factored it out. So now for number 9, let's go ahead and let's try that trick again. So 3x cubed is 3 times x times x times x minus 2x squared, so 2 times x, and then minus 1. So if I look across this, there's no common terms other than 1. So the GCF in this case is 1, and that's it. All right, so now this one, what they're asking us to do is to rewrite the x term to factor it by grouping. So remember, when we want to factor by grouping, what we're doing is we're taking that middle term and we're splitting it up like a bad boy band. All right, so I have my 35x squared, I have my plus 2, but that 17x, he's going to get broken up. Now the way that I do that is I'm going to set up a table. And so on that table, on the left-hand side, I'm multiplying a times c. So 35 times 2 is 70. So I'm looking for the factors of 70, and I'm adding in this case because my second visible sign is a plus. They've got to add to make 17. Let's see, so I know I have 1 and 70, 2 and 35, not 3, not 4, 5 and... Y'all miss C, needs a calculator sometimes too. Ain't no shame in that. 5 and 14. Doesn't go into 6, 7 and 10. Doesn't go into 8 or 9. So this is my factor list. And so when I add them, I get 71, 37, 19, and 17. So this is the set I'm going to use. So when I rewrite that 17x, I'm going to write it as plus 7x plus 10x. Because if I were to combine those like terms back together, I'd get back to the 17x. Now this one's not telling me to factor by grouping, so I don't have to take it any further. But that's just where we're at, where we split it apart. Alright, so let's go ahead, let's try that one more time. I'm just setting up my table. Now remember, I have my 12x squared, and I have my plus 3. So it's just this 20x that's going to be split up, right? Now because my second sign's a plus, I'm going to find the ones that add to make 20. So I take it and I multiply a times c. So 12 times 3 is 36, and I'm looking for the factors that add to make 20. Whew, okay, I have 1 and 36, 2 and 18. Now I could stop right there because that's 20. But just for funsies, let's keep going. 3 and 12, 4 and 9, not 5, 6 and 6. It's good practice to keep generating those lists just to get you thinking about it. So that's the set of terms that I'm going to use to rewrite 20x. I'm going to call it as plus 2x plus 18x. Now again, this is not telling me to factor by grouping, so I'm going to stop at this step. But from here, right, to factor by grouping, you set up your two sets of parentheses, the plus between, factor out your GCF, and then put the GCFs in one parenthesis and your non-GCFs in the other. Just so you remember it. Alright, and here are our last two problems, 12 and 13. What they want us to do is they want us to factor the trinomial to find some possible dimensions of the rectangle. Alright, so here on 12, we have an expression that that has a number in front of x squared that's not 1. So I'm going to actually factor this by grouping. So what I'll be doing is breaking up that 17x into two terms so I could group them. So right now I'm setting up my little table. I'm looking for the factors of a times c. So 5 times 6 makes 30. So I'm finding the factors of 30. And then I look at the second sign. So on the second sign they're adding, and we're adding to make 17. So the factors of 30, I have 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And if I add across, I get 31, 17, 13, and 11. So the ones that match are 2 and 15. So instead of writing plus 17x, I'm going to write plus 15x plus 2x, making sure that there's a plus in between them. So now I break them up to where that plus is between the two sets of parentheses, and I'm factoring out my GCF. So in that first set of parentheses, my GCF here is 5x, and in my second parentheses, my GCF is 2. So 5x squared divided by 5x is x, and 15x divided by 5x is 3. And in my second parentheses, 2x divided by 2 is x, and 6 divided by 2 is 3. Now my GCFs come out into the first parenthesis, and then the one that's copied is my second one. So this is my factored form for my dimensions. So this length is 5x plus 2, and this width is x plus 3, probably. So now, since I showed an example where I did factoring by grouping, on this next one, I'm going to do factoring by substitution, just to make sure that you guys are seeing both ways. So with substitution, my first step is to multiply by a. So my a in this case is 6, so that's what I'm multiplying by. So that first term turns into 6x squared. My second term is going to turn into plus 7 times that 6x. And then 6 times negative 5 is negative 30. And then I'm going to go through and I'm going to say, well, p is the same thing as 6x. And so I'm going to replace these with p's. So I have p squared plus 7p minus 30. And now I can factor that using double bubble. So I'll be finding the factors of 30. And that second sign's a minus, so I'll be subtracting to make 7. Okay, so I drop down my p's. 2 p's and 2 pods. It was funny last video too, I promise. My first sign's a plus, so it falls down. And my second sign is a minus here, which means that these have to be opposites. So now let's go ahead and let's deal with those 30s. So I know I have 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And when I subtract, I get 29, 13, 7, and 1. So you could see that this third set, the 10 and the 3, come down here. So then I'm going to go ahead and change those p's back to 6x's. Alright, so I get 6x plus 10 and 6x plus or minus 3. And I'm going to factor out their GCFs. So between 6x and 10, I have a GCF of 2. And between 6x and 3, I have a GCF of 3. Notice this takes a lot more steps in factoring by grouping, doesn't it? So 6x divided by 2 is 3x. Did I make a mistake somewhere? And 10 divided by 2. Oh, no, I'm good. And 10 divided by 2 is 5. Started thinking these had to match, like factoring by grouping, which is what made me think I was going wrong. But I don't, right? 6x divided by 3 is 2x, and 3 divided by 3 is 1. Now this GCF is 2 times 3 is 6. So I'm just going to leave those off for my final solution, right? Because I divide by 6 to get rid of them. So my final solution is right here next to Snow White, 3x plus 5 times 2x minus 1. And remember, you guys could always check yourselves by redistributing to make sure that your answers go back to that original problem. So there we have it, guys. That's the Do You Know How for 7-6. Until next time.